The work done by Nell, Carol Dweck, and others in the area show that growth mindset interventions in the area of math has increased motivation and excitement about challenge. As student researchers, we hope that by applying similar interventions to promote the growth mindset in introductory coders, we'll be able to achieve the same results: increased motivation, excitement about challenge, and a decrease in the gender achievement gap in computer science. Introductory students continue to drop out of introductory programming courses at rates of 30 to 50%, and studies have also shown that students taking introductory programming courses start off with more of a growth mindset and end up with more of a fixed mindset after the course. We hypothesize that promoting the growth mindset in computer science will have similar positive effects as in math, and hopefully increase retention in these programming courses. The research questions we hope to address are: by rewarding good coding practices, will people begin to associate their process to their outcome? 2, can we reward the process of coding? 3, can we give feedback to get people to recognize their process and attribute it to their outcome? And 4, how do we reward the process of coding for an older audience? However, throughout the quarter and the past 2 quarters, our research questions have shifted and changed. This quarter, we switched from using an Atom plugin to a CodeMirror web-based text editor, as seen on the right side of the video. Jamie helped us identify good coding behaviors and created heuristics to detect them that were elementary, but still things that we could use. We created automatic pop-ups so that while someone was coding, a pop-up would occur if they exhibited one of the good coding behaviors that Jamie had detected for. However, early in the quarter, we realized that the tech that Jamie had implemented would not be tech that we could rely on heavily to do any studies. This showed up when we did our in-class status update. The goal of the study was to test a few features in our interface, particularly whether a sidebar allowed students to remember their process better, more so than just having a point system. We also wanted to test the pop-ups in general and the points in general. It seemed that users with sidebars remembered how to describe the strategies just like we had phrased them. But some questions that we asked were that if they have the sidebar, do they describe the process they used in terms of what we told them with the sidebar? And if they have just pop-ups, do they describe the process they used in terms of what we told them with the pop-ups? We found that users who had the sidebars remembered the exact phrasing and wording that we used, while users who didn't have the sidebar but did have the pop-ups sometimes remembered the exact phrasing and sometimes didn't. However, overall, most users remembered what the pop-up said and understood what they were being rewarded for. We wanted to use results from the study to design a future study that answers the question of, does remembering the strategies impact mindset, or does just getting the praise impact mindset? From the status update, we also found that some pop-ups were very encouraging, and some people found receiving points fun, but others also found it frustrating when they thought they were doing the right thing, but the system was taking points away. For example, when people ran the same code twice. Additionally, some users thought that the encouragement was not useful since they already knew the coding strategies that we were suggesting. However, we hope that this would be more useful and more helpful for introductory coders. One of the largest takeaways that we got from the status update that we'll be able to use for our next study was that we need to work more on the interface. Students felt that they were adjusting to a new interface and understanding how to use the text editor, even though it was supposed to mimic something similar to Atom or Sublime. The bottom of the screen, where you can see a console, was supposed to act as a REPL. However, or that's how students thought it would act. However, it was more of a console that could just output the code ran in the top when pressing the run button. After doing the status update, we implemented a REPL in the console so that when you print a Python string, for example, or type Python code, it will print the output rather than just echoing what you typed in, which is what previously happened. Some of the limitations of the status update we did were that we can't really tell the difference between writing correct and efficient code or exemplifying coding practices. There are two different things, and some students mentioned that they felt like rather than trying to solve the problem, they were supposed to be trying to show good coding behaviors, where we had hoped that the two would be synonymous. However, the next big finding we had from the status update was that Jamie's tech would not be something we could rely on for our study to find concrete research findings and contributions. In order to solve that problem, we are planning to run a study next quarter using the Wizard of Oz technique so that we can trigger pop-ups while watching users code, instead of relying on tech to trigger the pop-ups at the correct time. We also scoped our research down into one slice that asks if directed encouragement when users are stuck in an error cycle can help them to overcome challenge and leave them more motivated in the long term. We're hoping that intervention will decrease the times that users spend helplessly flailing, and as a result, we hope this will increase their self-efficacy when it comes to coding. Our new research questions are: 1. Does intervening with suggestions to break the error cycle decrease time spent flailing and increase self-efficacy? 2. How can we detect flailing? And 3. How can we word messages to correctly convey the correct message to beginning level programmers in a language that they will immediately understand? The tech for this study will be very similar to the code that we used for the status update. However, we now have ways to trigger the pop-ups by simply clicking on F1 or F2. The reason that this will work is that we can use Chrome Remote Desktop to see the user's screen while they're typing and also type into the same screen. However, instead of actually typing into their code, we'll simply be pressing the F1 and F2 buttons so that we can trigger the pop-ups, and the user won't understand or won't realize that we have been pressing the buttons for them. Using this, the wizard will decide in which stage a user is in. We've broken out 3 stages for beginner programmers when solving a problem. The first stage is when the user is reinterpreting the problem prompt and searching for a solution. The second stage is when the user is implementing the solution. And the third stage is the debugging the code. While the wizard watches the user code, the wizard should identify which stage the user is in, and when they flail in that stage, the wizard should be able to trigger an appropriate pop-up to help the user get past their flailing and struggle productively. We hypothesize that intervening during an error cycle will allow students to struggle more productively and allow them to persist through this challenge and give them the confidence to persist through future challenges. We also hypothesize that an individual flailing will start to run their code without thinking about it, or they'll stare at the screen without any noticeable changes. These are 2 different ways that we might trigger the pop-ups when we see user behaviors. In order to recruit participants for the study next quarter, we will need Northwestern College students with minimal coding experience, but that do have knowledge of Python. This might be the EECS 110 class, which is taught in Python, will probably be our main source of participants. During the study, students will enter the room with a facilitator. A Wizard of Oz will be sitting in the corner of the room with a laptop, seemingly doing work. The facilitator will start the experiment and the wizard will trigger the pop-ups when they see the users flailing, and notes will be taken on how the user reacts. The user's screen will also be recorded, and their face will also be recorded so that we can detect facial expressions similar to the study we did in the winter, or in the spring. Users will be asked to complete coding challenges over the course of 40 minutes on a computer that is already set up in the hackerspace with Chrome Remote Desktop setup. They will then complete a self-efficacy survey that they will have also completed once before the study. This way we'll be able to see any changes in self-efficacy in coding as a result of our study. At the end of the study, the user will be debriefed, and we hypothesize ultimately that by intervening when students are flailing with directed feedback, they will have higher self-efficacy when it comes to coding.